smallest particles, or but actually smallest particles are also, because you know that electron, protons, and neutrons are there. Okay, and these are the subatomic particles. Okay, and we can simply say that if we talk about the atoms, so it is not the only atom which is the smallest particles. We know that, but we can say that it is the particles of matter which take part, or we can write it, it is the smallest particle of matter, because atoms is the smallest particle which take part, which participate in the chemical reactions. Okay, got it? Got it?
Yes, sir.
So write it down. An atom, an atom is the smallest particle of matter, is the smallest particle of matter. Okay, atom is the smallest particle of matter which takes part in the chemical reaction, in the chemical reactions. Okay, so it is the atom that is taking part in the chemical reaction. Okay, it is the atom that is responsible and which is taking part in the chemical reactions. So atom is responsible for taking part in the chemical reactions, and okay, generally different atoms show different chemical properties. Same atoms generally show same kinds of chemical properties. Okay, next is molecules. What is molecule? Molecule is, if I talk, what is molecule? When two or more atoms chemically combine together. They may be the similar kinds of atoms or different kinds of atoms. If they are chemically combined together, they form a molecule. So like oxygen, in oxygen, the two atoms combined together, they form one molecule of oxygen, O2. Like in, if I talk about different, like in oxygen here, OO atom combined together, they form O2. Nitrogen atom combined together, they form N2. And if I talk about the different, like in hydrogen and oxygen combined together, they form H2O water molecule. Okay, so what is a molecule? If I talk about that molecule, when two or more similar or dissimilar atoms chemically combine together, they form a molecule. If they are similar atoms, it form homoatomic molecule. If they are different atom, they form different or heteroatomic molecule. Understood? Understood?
Yes, sir.
So noted down molecules when two or more similar or dissimilar atoms chemically combined together, they form a molecules. Okay. When two or more similar or dissimilar atoms chemically combine together, they form a molecule. One, if I talk about this, is if similar, it is H2, O2, N2, Cl2, Cl2, Br2, I2. These are homoatomic molecules. Okay, these are homoatomic molecules. These are homoatomic molecule. And if I talk about the next one is like, for examples, if I'm taking another example, like one nitrogen atom and three hydrogen atom chemically combined together. Okay, this form ammonia molecule. The name of this molecule is ammonia molecule. Okay, molecules. Okay, like we talk about this next one is like H2O molecule, like sulfur dioxide, like sulfur trioxide. Okay, like there can be carbon dioxide. So these are all molecules. Here the different atoms are combining together to form one molecules. Okay, got it? Now you understood? Tell me, understood?
Yes, sir.
Next, for this next one, yeah. Do the what is cations and anions? What are cations and anions?
So can I say
Yeah.
cations are the uh, charged particles which contain positive charge, and during a chemical reaction, cations are lost, and anions are the ions which have negative charge, and in a chemical reaction, um, anions gain an electron.
Okay. 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 Yes, you, Alvina. What's your answer? What is what is cations and anions? What is your answer?
Um, Cations are positively charged and are attached to the cathode, whereas anions are negatively charged and are attached to anode.
Ah, okay. So give me examples of this one. Give me examples. Give me the example, please.
Um, in MgCl, Mg magnesium is the cation and Cl is the anion. So in a chemical reaction, magnesium will lose its electron and anion.
Okay. So let's talk about this one. Like what are cations and anions? So cations are the positively charged species. Okay. What is the difference between cations and anions? So cations are positively charged species and anions are the negatively charged species. Okay. But it is opposite to the cathode and anodes rays. Okay. If you talk about that. Okay. So here, if I talk about this one is cations, these are positively charged and these are positively charged ions which are formed by gaining of electron or losing of electrons.
Losing of electrons.
Yeah, these are formed by losing of electrons. Okay, so we can say that these are the positively charged ions which are formed by losing of electron. For example, like Na, 1 positive, okay, K positive, zinc 2 positive, barium 2 positive, aluminum 3 positive. So the number of electron they are having right now, they have in charge, they have loosened that number of electrons. Okay, now talking about the anions, we can simply say that ions are of two types. Ions are the subatomic particle which are having the charges. Okay, sorry, the atomic atoms with charges are called ions. If they are carrying the positive charge, they are called cations, and if they are carrying the negative charge, they are called anions. So if I talk about anions, so anions, these are the these are the negatively negatively noted down charged particles which are formed by gaining of electrons, which are formed by gaining of electrons. Got it?
Yes, sir.
Example, Cl minus,
Cl.
Cl minus, O minus 2, N minus 3, okay, Br minus 1, okay. So we can simply say here that these are the negatively charged particles which are formed by gaining of electrons. When a neutral atom gain electron, it form, okay, negatively charged, it form anions. Okay, got it? For example, chlorine, oxide ion, chloride ion, nitride ion, bromide ion. So these are considered to be as anions. Okay, got it?
Yes, sir.
Next. Next question. Next part of this one. What is the difference between molecular formula, molecular mass, and formula mass? What is the difference between molecular mass and formula mass? Tell me. Tell me. Tell me. What is the difference between molecular mass and formula mass? No, don't know. So molecular
Um,
mass, yeah. Tell me.
I don't know what unit mass properly, but molecular mass is adding the masses of the atoms.
Yeah, but it is actually not. I will give you the mass for this topic, but actually, molecular mass is the actual mass of the formula. Okay, it is the. We can say that molecular mass is the actual mass of a molecule. Okay, like for example, if I'm having C4H10, okay, this is the actual mass. We will calculate it. How are we going to calculate that? For example, 12 into 4 plus 1 into 10, you will get 12 for the 48. Okay, and plus 10. So 48 plus 10, whatever you get here, you will get the molecular mass here. Okay, molecular mass 48 plus 10, you will get 58 as the molecular mass. But actually, when you cut it, when you bring it into the simplest form, you see 4H10. Okay, so its formula will be, actually you cut it by 2 and you compress it, you will get how much? You will get 2 and 5. So its formula mass will be that is 2 into 12 plus 5 into 1. That will be 24 plus 5, and you will get 29. Okay, 29 is the formula mass. So it should be in the simplest form. Okay, that is called its formula mass. Got it? So, but let it be. This is not going to be so important. Next question number 10. Justify the given statement that most of the empty space in an atoms are empty. How will you justify this one?
Because atoms contain electrons which have minimal mass, and um, because of that, the atom is mostly empty.
Yeah. So we can simply say that when the Rutherford was doing an gold leaf experiment was done. Okay. So by the not by the Rutherford. Yeah, by the Rutherford. Yeah. So he gave the, and in the gold leaf experiment, we found that most of the alpha particles goes there undoubtedly. So this indicate that. So what's the answer for this one? Simple. That justify the reason, give the reason that why most of the space in atom is empty. So in the gold leaf experiment, when it was doing, so we find that most of the rays were going undirectly, without any deviations. They were going. So it means that it has lot of empty space. Okay. This one. Are you getting my voice?
Yes, sir.
Yes.
Okay. Okay. Next. This is the reason. So should I write this answer for this one, or you will be able to write it out by your own?
Yeah, you're right, sir.
Do I need to write it?
Can you
Yes, sir.
repeat the answer, sir?
So
Your
let
voice was breaking.
my voice is lagging now. Okay, let me write it again for you. It's 1 minute. Obviously, looking at a higher resolution. Okay, let's move on this part and let's discuss these questions. So the answer for this question is in the Rutherford gold leaf experiment, in the Rutherford. Is the screen is visible to you?
Yes, sir.
gold leaf experiment. Okay, in the Rutherford gold leaf experiment, gold leaf experiment or gold leaf alpha particle experiment, we find that most of the alpha particles were moving undirectly, means without any deviation, they were just passing through it. So it means that atoms have a lot of empty space. Okay, otherwise, if the most of the alpha particle get deflected, means it is going to have some charged particles and it is not going to have very much empty space. Okay, got it? Okay.
Yes, sir.
So in the Rutherford gold leaf experiment, most of the alpha particle goes indicating atoms have lot of empty space. Okay, so in the Rutherford gold leaf experiment, most of the alpha particle goes undeflectedly, indicating atoms have lot of empty space. Okay, next question. Question number, the elements are identified by their atomic number, not by their atomic mass. Why?
Because some atoms have this, because some elements have the same atomic mass, but they don't have the same atomic number. For example, calcium and argon, they both have the atomic mass as 40, but their atomic numbers are not the same.
Okay, let's discuss this one. This is an important and very important question. Okay. This is very important. So we need to discuss this one. So the elements are identified by their atomic number, not by the atomic mass. What is the reason behind this? Why the atoms are being identified by their atomic number, not by their atomic mass? The reason behind is that the atomic number is the number of electron or proton present in the atom. Okay, and electrons are the one that participate in the chemical reactions. Okay, and when the atoms have the atomic number, so they have the fixed number of electrons, and these electrons participate in the bonding. And moreover, the number of electrons in an atom is fixed. No two atoms can have same number of electrons. If I'm talking about that, it is the atomic number. No two element can have the same atomic number. Means the same number of proton and electron. It cannot. No two elements can have. That's why an atom is identified with its atomic number, not by its not by its atomic mass. Okay, got it? Got it? So what's the answer for this one? What's the answer? Tell me.
For the 11th one,
Yeah, the 10th B part. Again, you have to answer the question. 10th B part. What's the answer for this one? Tell me. Okay, I'm going to help you. So note it down. Atoms. Atomic number. Atomic number is the number of electron or proton present in an atom. In an atom, okay? In an atom. And it is the number of electron that participate in the chemical reactions. Okay. So if I talk about that for this one, so you need to understand that atomic number is the number of electron or proton present in an atom. It is the number of electron or proton present in an atom. and the number, as you know, that it is the electron that are participating in the chemical reaction. The electrons are responsible for the chemical properties. Okay, if we have same number of electron in the outermost shell, they generally bear the same chemical properties. Like for example, if we talk about that sodium electronic configuration is 281 and it is 2882 is 2881 is the potassiums. Okay, and so they have the same number of valence electron or outermost shell electron, so they generally bear the same chemical properties. So it is the atomic number that is responsible for the okay, for the chemical properties of an element. And moreover, no two atoms can have the same atomic number. No two atoms can have the same atomic number. If they have the different atomic number, they are different. Why? Because they show different chemical properties. Okay, so we will say that atomic number is the identity of an element, because no two atoms can have the same atomic number, or the same number, or we can say that no two atoms can have the same number of proton and electron. Okay, if they must have different electrons and protons. Okay, got it? So note it down that two atoms no two atoms can have same number of electrons and protons. No two atoms can have same number of electrons and protons. Okay, that's why atomic number is the identity of an element of an atom. Got it? So no two atoms can have same number of electron and proton. That's why atomic number is the identity of an element. Okay, got it? Understood?
Yes.
Next. Question number 11. You done this question number 11?
Only the first part.
You did the first part. The atoms of an element, if I talk about the atoms of an element is R, S, and T, have this number of proton respectively. Okay. Neon has 10 proton. Okay, which write the chemical formula of the compound between R and T and S and T. Okay, let me help you. So if I'm talking about this question, that this is R, S, and T have the number of protons. So this respectively. So it has 8 proton, it has 9 proton, and it has 11 proton. And neon has 10 proton, we know. Okay, what is the chemical formula of the compound between R? What is the chemical formula of the compound between first is R and T and S and T? So R is going to have atomic number 8 and T is going to have atomic number R and T is going to have atomic number 11.
11.
Okay, 11. So when you write it 11. So what's the electronic configuration of this one?
R will have valency of 2 and T will have 1.
Yeah. So we'll say that it has electronic configuration 2, 8, 2, 6, and it has electronic configuration 2, 8, 1. So its valency is 1 and its valency is 2. Okay, it says valency 2. So it is positively charged because it will lose electrons. So we'll write it like this way, T here and R here. And write here valency. Its valency is 1. T's valency is 1. So write here 1. And that of R is 2. So write here 2. And you cross multiply simply, you will get TR2. T2R. Okay. T2R. Similarly, what's the valency between S and T? What is the chemical compound within S and T? Tell me. For S and T. For
S
S
will
and
have the valency of -1. T will have the valency of 1. They both cancel each other out.
yeah. No. Yeah, they will cancel. And what's the formula? ST?
ST, yes.
Yeah. So similarly, this S is going to have the atomic number 9. So its valency, its electronic configuration will be 2,7, and so its valency will be
minus
1.
1.
Yeah, 1 or 1. Okay, so this is we'll write here T and S. It is +1, it is -1. You cross multiply these two, or you will cancel out each other because they are. So this will be TS or ST. You can write it like this way. And what is the molecular formula of R? What is the molecular formula of R? Because R is 8. We'll say that. So its molecular formula. What is the formula of its molecule? So you know that R is actually 2,6, 8 atomic number. So it is oxygen. We can directly say that it will be R2. Don't write O2. What is the molecule? What is the formula of the molecule of R? You can write it R2, okay, or O2. Okay, got it? Question number 12. You understood this question or not? Tell me first.
Yes, sir.
Question number 12.
Yes.
You do question number 12. Relative atomic mass of copper is 63.5. It exists as 2 isotopes. What is the percentage it exists? Tell me. What's the percentage it is going to have? Have you calculated the percentage? Tell me fast. Have you calculated the percentage of this one in your
No, sir.
examination?
I
No.
left this
No, sir.
question.
Why you left this question?
I didn't know how to do it.
Relative atomic mass
Yes,
is given to
sir.
you 63.5. One is 63. So let's do this question. And this is a very important question. Relative atomic mass of copper is 63.5. It is being given to you. And the two isotopes are given like this and this. Okay, calculate their mass percentage. What is the percentage of these two? So we can calculate this one by in a very simple manner. Okay, so let's do this one. Yeah. So here it is a 63.5 is the average atomic mass. Average atomic mass 63.5. Okay, and the two isotopes of copper is going to have how much? This is 29. This is also 29. And what are their mass? 60. What are
63
they?
and 65.
63 and 65. Okay, so let's do this one. This is not a big deal. So what is the formula for the average atomic mass? Tell me.
Atomic mass of isotope A by atomic number into 100 plus
Yeah.
atomic mass of isotope B by atomic number into 100.
Yeah. This is very simple. That if you consider that this percentage, it's this the percentage of this element is X, and the percentage of this element is this will be 100 minus X. Very simple. We know that average atomic mass of copper, it is being given to you 63.5. Okay, and these are the two isotopes of copper. So if it exists X% in the nature, so this will be automatically 100 minus X%. Now the formula of average atomic mass is actually the mass of the first element, mass percentage of the first element. Okay, to remove the sign, we divided by 100, mass percent of the first element into the mass of the first isotopes. Okay, so mass of first isotopes, okay, then plus sign, and then mass of the mass percentage of the second element, 100 minus X, okay, upon 100 into mass of the second isotope. So write it 63.5. An average you get considered 100 X upon 100 into mass of the first is 63 plus you wrote here that will is 63 65. So right here 60, sorry, write the 100 minus x, and then put it in bracket upon 100 into 65. Okay. So now you just multiply this one, you will get 63x upon 100 plus you multiply this one and this one, you will get 6500 minus 65x upon 100. And now you this is 63.5, it is going together. Okay. Now I'm just solving the RHS part only. RHS part. Okay. Just write 63.5 is equals to, this is 63x, and this is both, they are going to have 100, and so we'll write 100. I take the LCM. This is minus of 65 and then plus of 65x, minus of 65x and then plus of what? 6500. Got it? Got it?
Yes.
So this will be
Yes, sir.
63.5 will be equals to, when you subtract it, you will get how much? You will get minus of 2x, and here you will get plus of 6500. Okay, 6500. Then what you are going to do is this 60, this 100 here is going to multiply this way. And when it is going to multiply with them, you will get 6350 is equals to minus of 2x and then plus of 6500. This minus of 2x will goes to that side, will become positive. You write 2x is equals to, and this will goes to that side, will become negative. 6500 is already written here. So right here minus, because this will become positive and this will goes to that side, will become negative. So 63500. So when you subtract it, you will get 150. You will get 2x here. Okay. Got it? Got it?
Yes, sir.
Yes, sir.
So what is the value of x is you are going to get here? So
150 divided by 2.
you will get,
75.
yeah, when you divide by 2, you will get 75%. So if we have, which one we have considered as which one we have considered as x? 63 isotopes. Okay. So
Yes, sir.
yeah, so if I talk about that, this isotope is x, so this will be 75%, and this isotope is
20.
25%. Okay. This is 100 minus x, 100 minus 75 will get 25%. Got it? Please copy this
Yes,
one.
sir.
Copy this one. Done?
Yes, sir.
Okay.
Finished.
Next question. Next question number 13. Question number 13.
I don't know how to do so.
You don't know how to do this question.
No.
Alvina, you there?
Yes, sir.
You still don't know?
No. Sir, I left these 13, 14 questions for an exam.
Why you left the 13, 14 questions? That's not good. Hmm? Alvina, that's not fine. Why are you doing like this? And you, Arya, why are you doing
Uh,
like this? You are a good
I
student.
think I think I did it, but I don't think I got it correct.
You did, na?
But I didn't get it correct.
Okay, you didn't get correct. Okay. So let's meet up. Let's talk about this one. Okay, doesn't matter. So in this question, what is being given to you in the following reactions? This is sodium nitrite when it is heated. Okay, it will give you sodium plus 3 molecule of nitrogen gas. If we have 750 grams of this one, and it when it decompose, when we have 750 gram of this one, and then it decompose to give this much grams of sodium. This is given going to give you 265.20 grams of sodium. Then how much grams of nitrogen is going to produced? So this is very simple. You have this much of this one. When you are getting this much amount of this one, so subtract this one. Whatever the answers you will get, the nitrogen amount of nitrogen. The total amount, this is law of conservation of mass. The total mass of the reactant must be equal to the total mass of the product. So if we have 750, you subtract it 265.20. You will get 0.80. You will get 9 here. 9 minus 5, you will get 4. Okay. And then is
484.8.
okay. Then you're going to have 4 here. 4 minus 6, how much you are going to get?
484.8.
4. Okay. And here we'll get 8. And then it is 6. Okay. Then 6 minus 2, you will get 4. Okay. So this is very simple that you will get 484.80 grams of nitrogen gas we will get. So this is very simple. When you decompose this sodium nitrite, and if you are getting this much amount of sodium, then the amount of nitrogen that you will receive, subtract it, you will get the answer. Now it is saying that like the B part of this one is that on hitting 20 gram of calcium carbonate, we get this much grams of carbon dioxide. Calculate the amount of calcium oxide formed. This is very simple. Oh, this is a very simple question. Calcium carbonate is CaCO3. Okay. And you have 20 gram of this one. When you heat it, you will get calcium oxide plus carbon dioxide. And you, how much amount of carbon dioxide you are going to get? You are getting 8.8 grams. So what is the amount of calcium oxide you are going to get? This is very simple. You just subtract it from this one. You will get the answer. 20.0 when you are subtracting 8.8 or 8.8. So what you are going to get here is you will going to get 11.2. So this will get 11.2 grams. Got it?
Yes,
Got it?
sir.
I am not sure that you had done this question wrong. 5 marks question gone. Hmm? Okay. Now for the question number 14, what you are going to get? Tell me. Tell me. Why is the ions of element X dot Y contain 13 proton, 14 neutron, and 10 electrons? What is the nucleon? So this is very simple. How you can do this one? Tell me.
Nucleon of X will be 7
Hmm?
or 14.
Okay, let me help you. That if you are what are nucleons? So here is Y. Y is the ions. Okay, Y is the ions of an element X and Y. So if I talk about that, Y is the ions of a element X, element XY. It should be compound of a compound. Okay. Uh, of an element X, sorry, of an element X. We are having dot here. Okay. So let it be. It is an element X. Okay, and it is an anions. Ions. Okay, it has loosened some electrons. Like Y contain, which is an anion, it contains 13 proton, 13 positively charged proton, and 14 neutron. So proton and neutron is neutral. It is not going to have any charge. They togetherly form nucleons. So what's first answer? What is the nucleon of Y? What is the nucleon number of Y? The nucleon number of Y is 13 plus 14, you will get 27. 27 is the nucleon number, and we will say that it is also the atomic mass. Atomic mass. Got it? Got it?
Yes.
Nucleon means, what is nucleus? Nucleons means the number of proton and neutron that lives in the nucleus, that remains in the nucleus, that's considered to be as nucleons. Okay, draw a dot and cross diagram that show the electrons arrangements in and of element X. And now it is saying element X, not the ions. Okay, element X. So it is going to have 13 protons. So it is going to have the atomic number 13. So it is okay. So it is aluminium. Indirectly, we can say that atomic number is 13 because it is going to have 13 proton. So electron, you can say that this is the first shell is going to have 2 electron. The second shell is going to have 1, 2, 3, 4, 5, 6, 7, 8. And the third shell is going to have, okay, 3 electrons. So this is, okay. And 10 electrons it is, means it is aluminium 3 positive because it has loosened 3 electrons. So X is actually, X is aluminium because it is an element. This is X, okay. And if I talk about this one, that Y is an ions, which is a positively charged ion, and it is Al3 positive. Okay. Predict the formula of Y. Y means Al3 positive. Okay. With an oxide ion. So don't, because it is saying Y, it is not saying that you have to write the aluminium. Don't write aluminium. Okay. We will say that Y is 3 positive and X is only. If it asks that what is X, what is Y, then we will write it. That Al is Y, X is a aluminium atom and Y is aluminium ions. But it is not asking, so we'll leave it as it is. Now, what is asking? Aluminium and Y. So Y is aluminium and oxygen, it has valency 3. Why valency 3? Because it has loosened 3 electrons. How we know that it has loosened 3 electrons? Because it has 10 electron right now, and it should have equal number of proton. When electron should be equal to number of proton. So it should have 13 electron also, but it has only 10. So it means it has loosened 3. And if it has loosened 3, it means that its valency is plus 3. Okay. And oxide ion has 2 valency. So you cross multiply. So you will get the answer as Y2O3. This is the formula. Predict the formula. Understood? Tell me fast.
Yes.
Sure.
So
Note it down, please. These questions and it's along with the solution. Note it down. Whole formula you have to write it. Write each and everything properly. So we can write it like this way. We can write it like this way. So in the previous question, the first part is nucleons. Nucleons. So nucleon is number of proton plus number of electrons. Sorry, number of neutrons. That is equals to, it is in 13 proton and number of neutrons are 14. So that would be 27 is that. And second, it is asking that element X is an ions which is having 3 positive charge. Why? Because it has loosened 10, it has only 10 electrons. So it should have 13 electrons as number of proton equal to the number of proton. But since it has only 10, so it has loosened 3 electrons. So it is asking that what is the valency? So valency for Y is, sorry, X. For X is 3 because it has only 3 electrons. Okay. And in the third part, it is asking for the formula of Y with O, with oxide ion. Y with oxide ion. So here you can write it. Y has valency 3 because it has 13 proton and 10 electrons. 10 electrons, so it's 2, 8. So it has plus 3 charge because it has loose, and oxide has 2 valence. You got it, you will get Y2O3 is the answer. Got it? Got it?
Yes, sir.
Have you noted the question? Note it down properly.
Noting, sir.
Okay, note it down. Should I means the question is you are having the questions paper. So
Sir, can you go to the previous page?
to the which part? To the question part.
The
This
question
one.
part. Yes.
And it is asking for the electron cross structures.
Done, sir.
Okay. So is there any question that you specifically are having doubt in this question paper? We will send you the recorded video lecture for the whole question in very short, okay, and in the short form. Okay. So I hope if there is any questions, so we have discussed this question from we started discussing question from 8, question number 9. Okay. Question number 8. Carbon react with oxygen. Oh, we have left this question. What's the answer for carbon when react with oxygen in ratio? What is the way? Yeah, tell me. Here is one important questions that is remaining. Carbon and oxygen react with each other in ratio. Carbon and oxygen, when they react together, they form carbon dioxide. Okay. So in their ratio is 3:8. Okay. If I talk about that, the weight of carbon that should be used to completely react with 40 gram of oxygen. So it is 40. So we multiply this by 40 to make it 40. So this should be multiplied by 5. So okay, if you are having 40 gram this one, so the weight of carbon that will be required, that will be 15 gram.